AP Problem 13 says account for each of the following observations about pairs of substances. In your answers, use appropriate principles of chemical bonding and or intermolecular forces. In each part, your answer must include references to both substances. Okay, so part A says even though NH3 and CH4 have similar masses, NH3 has a much higher normal boiling point, negative 33 degrees Celsius, than CH4, negative 64 degrees Celsius. So, the reason for this is that NH3 is polar and has hydrogen bonding and London dispersion forces. CH4, on the other hand, is non-polar and it has only London dispersion forces. Hydrogen bonding is much stronger compared to London dispersion forces in the CH4. So, because of the stronger forces, it has a higher boiling point. Okay. Part F says at 25 degrees Celsius and 1 atm, ethane, C2H6, is a gas, and hexane, C6H14, is a liquid. So, the reason for this is the intermolecular forces are London dispersion forces in both C2H6 and C6H14. However, C6H14 does have a higher boiling point, and that's because hexane has more electrons and it's larger than C2H6. You can clearly see that. This has more atoms. This one. And because it's larger and it's more, it has more electrons, it has stronger London dispersion forces, and the stronger London dispersion forces keep it together more. So that's why the larger molecule is a liquid while the smaller one's a gas at the same temperature and pressure. Okay, the next part, G, says Si melts at a higher temperature, 1,410 degrees Celsius, than Cl2, negative 101 degrees Celsius. So obviously these are very different, and yeah, there's a reason for that. So silicon atoms covalently bond to each other and create a macromolecule. So all the atoms in a silicon sample are kind of bonded together through these covalent bonds, and it's a very large molecule. And then Cl2, on the other hand, is just two chlorine atoms bonded together covalently, and then those those molecules are attracted by London dispersion forces. So those small little atoms kind of aren't really very closely attracted. So these London dispersion forces are much weaker than the covalent bonds the Cl atoms bond together with. So the energy to overcome the strong covalent bond to melt Si is much greater than the energy required to break the weak London dispersion bonds in Cl2. Okay, the next question, H, is MaO melt at higher temperature, 2,852 degrees Celsius, than NaF, 993 degrees Celsius. Okay, so we know that MgO and NF are both ionic solids. They're between nonmetal and a metal, and they transfer electrons, so they're both ionic. The difference between them is the amount. So Mg and O transfer 2 electrons between them, and NaF transfer 1 electron between them. And the 2 and the plus 2 and negative 2 charge that results because they're transferring these two electrons is much stronger than the one electron that N and F are transferring, and the force that happens between them. So because of this, the intermolecular charge of MnO is stronger than, or the intermolecular forces, of MgO is stronger than NaF, because just there's more basically polarization, because one end, or there's just more charge happening, so they're way more attracted to each other.